Hello, battery fans. I think you know I am, but just in case, I'm the PC expert amateur. Yes, expert and amateur, because there are lots of things I know and lots of things I don't know. What I don't know, my sister knows, but shh, don't tell her. I don't want her to get a big head. All right, seriously though, this episode, or whatever you want to call this video, is focusing on rechargeable batteries and also chargers. I'm going to be going through things in a I'm going to skip a lot because just the topic of batteries is massive. I did the research on this several years ago, and I just never got done with it because it was so involved. And since then, it's gotten even bigger than it used to be. So it takes a lot of effort to really understand. And even if you research this for quite some time, just looking at publicly available common batteries, there are dozens of them. And then if you look at what the market being flooded by China, there are so many brands coming out of China nowadays that are Chinese brands, and some of them are really, really, really good. I mean, if you look at Project Farms, they've done some reviews of batteries recently, and my gosh, it's mind-blowing. Now, that said, there are bad products coming out of China. There are also bad products coming out of America and out of other places as well. So it just depends. I mean, you can't just say just black and white, China sucks, America's great, or China sucks, Europe is great, or Europe sucks and America sucks and China is great, or whatever. None of those apply. Primarily because so many things are made in China, and some of those Chinese people are just in it for a fast buck, and some of them are in it for the long term. They want to make a name for themselves. They want to have a long-term company. So I assume that most of you are familiar with the most common types of batteries. For example, AAAs and AA's, and like that. That's a AA. And then there's also single A's and quadruple A's and B and C and D, which that just keep on getting bigger. So it goes from 4A all the way up to D, and these are all cylindrical. Then it goes to E, which is more commonly called the 9-volt. And I know that there are plenty of people that are not even aware of that because for whatever reason, the term E just kind of disappeared from when I was a kid, and it was used, and I just came across it just recently, and that reminded me about it because I had forgotten about it. It had been so darn long. But on top of those, there are lots of lithium batteries, and there are silver oxide batteries, and there are then the proprietary batteries, the batteries for specific devices that sometimes require specific charges made by the same manufacturer or for the same manufacturer. So I'm not going to be looking at the entire range of batteries. And I'm not going to go too deep into this again. So aside from the ones I've mentioned so far, there's also the sub C. There's also the 1/2 A. Then there is the F6. Of course, there are button batteries of different kinds. I'm not really going to be talking about the button batteries because, honestly, I have yet to see rechargeable button batteries, which is surprising to me because they should be rechargeable. And I'm sure there are some, but I just haven't seen them. So let's start with chemical types. For example, there's NiMH, which is nickel metal hydride. And then there's NiCad or NiCd, and that's nickel cadmium. And by the way, cadmium is a dangerous chemical, right? There's also a bunch that, for whatever reason, there are always disagreements between different countries, even between different companies within one country. And there are so many examples of this where one company has their proprietary technology and they want that, and the other one wants their proprietary technology, and one ends up usually winning because of marketing, not because it's better, which is just stupid. We have lost technology because the better marketed product won out over the better product. But I'm not going to dwell on that. So one category is the I batteries, or IMR, ICR, INR, and IFR. So the I stands for, strangely enough, lithium. When it comes to M, it stands for manganese. C stands for cobalt. N stands for nickel. F stands for iron, like Fe. So the second letter makes sense because manganese is Mn, cobalt is CO, I believe. Nickel is Ni, and iron is, well, because of the obsession with Latin and Greek, iron is Fe, which is where we get the word ferrous from, or and ferric, and ferritin, and so on and so forth. The R has nothing to do with chemistry. It means round. And they all have it, so it's kind of like, okay, they're not round, they're cylindrical. Why bother? Anyways, let me be more specific. IMR is lithium manganese, or LiMN2, LiMN2O4. And then ICR is lithium cobalt, or LiCoO2. And INR is lithium nickel manganese cobalt, or LiNiMnCoO2, because this also got the oxide. So that O2 or O4, that's oxide. And then the IFR is also known as LiFePO, and that is lithium iron phosphate, and then the oxide, of course. Now, the list just keeps going on. And then there's the lithium ion category, which uses a range of chemicals within them. And then there's the LiFePO 4 batteries. So that's Li, lithium, Fe, iron, P, which is phosphate, and then O4, which is an oxide. And so that, and within that category, we've got lithium cobalt oxide, which is LiCoO2, lithium nickel manganese cobalt oxide, which is LiNiMnCoO2, lithium titanate, which is LTO, lithium manganese oxide, LiMn2O4, lithium nickel cobalt aluminum oxide, LiNiCoAlO2. It's just, there's just so many of them. Then there's LiPo batteries, which use a polymer electrolyte and are less safe than lithium ion or Li-ion, and LiFePO 4. So there's all that. It gets kind of complicated. And this is just scraping the surface. These are the ones that are very common. Now, when we talk about the lithium batteries, setting aside like button batteries, there are a whole range of them starting from 10,000 something to 30,000 something. Like this one. This is an 18650. It's a little bit exasperating. Each different chemical composition has strengths and weaknesses, and I'm going to show you some of the information, just a little bit, so you can wet your lips, so to speak, and fry your brain at the same time. Because, you know, that's what happens when you put your tongue on a 9-volt battery to test and see if it's still good. You know, it hurts, but if it's a weak zap, then you know that 9-volt battery is no longer useful. So, and I would definitely recommend, don't buy disposable batteries anymore. It's a huge waste of money. I mean, the cost of them is insane these days. I every time I go and look at them, and so I've just stopped buying them. I got myself some rechargeable batteries. I don't have the 9-volt yet, or the E, but I'm going to get that too, because I use AA, AAA, sometimes C or D, and 9-volt. I've got a bunch of C's, but I've never used them, and they're probably already leaking because I've had them for years now. But okay, so there's a whole range from 10,000 to 30 something thousand. And I didn't even go into that. I'm not going to go into that with you. Aside from chemical composition and these numbers and the letters, there are a bunch of things that when you're looking at buying the charger, because not all chargers are made the same, which, there are different reasons for that. And one of the reasons is because of all the different chemicals. Like there are some, and the different sizes. So like, for example, this one can only do small batteries like that. AA and AAA. It's a Chinese brand called Wenjup, which is probably trying to play on the famous brand Eneloop, which has been around for a long time, is pretty expensive and fairly reliable. More highly reliable than a lot of other brands. It's made a name for itself. But when these companies try to play off of popular names, like I bought a pair of earphones that were JLB, and they said it's an American-based company. So I was like, is that? I was confused, and I was thinking JBL, and that was their intention, to mention JLB plus American-based, which is not the same as an American company. It confuses consumers and makes them buy the product because they think they're getting that well-known brand name product for a low price. Not even talking about the counterfeit products here. So I've got 3 examples of battery chargers. There's the Wenjup, which only does AA's and AAA's. And then there is the Yongfeng County Fohi Electronics Factory, obviously Chinese. And they also charge AA and AAA's. And there's a Wenjup battery right there. It actually, came with the Wenjup charger, of course. So this also only does AA and AAA. Now the difference between this one and this one, you can see a couple of differences. This one has the built-in cable. This one instead has a foldable double prong there for you to plug it in that way. So USB or wall power. Strengths and weaknesses. Wall power can give you a higher amount of voltage than USB, which is limited to 5 volts. But this 5 volt one has an individual indicator for each of the slots. Whereas the Wenjup, what does the Wenjup have? There's nothing, which can be very aggravating because it's hard to tell then, well, is it done or not? Now, there are a lot of battery chargers that don't have any LED indicators, or some of them only have one LED indicator. It is charging some or all batteries. This one actually has LED indicators. You just can't see them until it's plugged in. So give it a second. And now you can see that first it was scanning. Now it's going to charge. This one's charging. When it's done charging, the light will turn out. If you buy one that doesn't have any LED indicators, it's frustrating because you don't know when they're done. And it can't guarantee it's done based on a certain time frame because it depends on the milliamp hours. Like this one is a 2800 milliamp hour battery. And this one is an 1100 milliamp hour battery. What that number means is the higher that number is the longer it's going to work before it runs out of electricity. So that's something you have to consider when you're buying batteries. The smaller the number is, the cheaper it's going to be, but the faster it's going to run out of electricity. Now, if you have a purpose where the device only uses a little bit of energy at a time, buying a cheaper low milliamp hour battery is fine. But you should also look for one that is designed for low power usage. There are batteries designed for low, medium, and high usage. So they give out, the amount of current that they provide at any one time is either low, medium, or high, somewhere in the range, right? It's not actually just 1, 2, 3. It's a range. So buying one of these where you have LEDs all for each of them is nice, because at least you know something's happening. And I can show you with this one as well. You can see that this one also is charging 2 batteries. I mean, I can throw more batteries in here. So you can see all of those are charging. Once the batteries are charged, the light will turn off. So that's really convenient. Is it the most convenient? Well, for the average user, you would say so, right? So, there are some things that matter for when you choose batteries, a lot of things really, because there are so many different kinds and they're designed for different purposes. Some batteries are safer than others. Some batteries give a larger amount of electricity at a time. Some give it a smaller amount. Some produce a lot of heat. Some are prone to bulging or starting on fire more readily than others. Some are great for vehicles and stuff, and others are great for consumer devices. So it all depends on the purpose. They're not like, oh, just mix and match. Oh, I'm going to get this one, I'm going to get that one. Ideally, you should be looking at what you're using the device for, how much electricity it needs, and then you get a rechargeable battery that matches that. So you get the best bang for your buck. You might want to put like an indicator on the battery so you don't forget, so that you'll see, oh, it's A. That means this is for this kind of battery purpose. Or you could put something more purpose-driven, like if it's a low power, then you could put LP and something like that. It's up to you. But you have to look into it. I'm sorry, I'm not going to go into that in this video. It's so involved and so complicated. I will show you a little bit of information right now, if you just hold on a second here. Okay, so just looking at the 3 kinds of lithium batteries I was talking about before. We have the LiFePO4s, or lithium iron phosphate batteries. It shows you chemistry, safety, cycle life, voltage, energy density, and application. Then the Li-ions and the LiPo batteries. So you can see that each of them has pros and cons. All right. So I'm just going to leave that on here for a moment longer, and then we're going to go to a different one. And here is a little bit more information about different LiFePO batteries for different purposes. And also, I'm sorry, let me pause and look at that. And a summary of why you should purchase a LiFePO4 battery. But they're not for everything. And then here's some information about other types of batteries. AGM, gel, lead acid, and we can see the pros and cons very briefly of those. There's also a little bit of information here about the IMR, ICR, INR, and IFR batteries I was talking about, strengths and weaknesses of each of those, safety and longevity, applications, and performance characteristics. So if you want the ones that are the safest, then you're looking at IMR and IFR. And if you want a balance between safety and performance, then you want INR. If you have a purpose where ICR is best, like high capacity, then ICR is the best. But you're going to want to have something that will drain off the heat so it doesn't become a fire or an explosion. And definitely you're not going to take ICR batteries on the airplane. So there's all that information. And if you go to Wikipedia, there's a huge amount of information. I don't think it has everything, but there's a huge list of batteries here that you can browse if you're curious. Even some proprietary batteries for specific devices. So there's so much to go into if I wanted to go down the rabbit's hole, which I don't want to do. Absolutely not. Setting aside types of batteries, and now that we've talked about LEDs, don't get one that only has one LED for all of the slots. Every slot should have its own LED. If you see only one LED, you have to use all of the slots. or there's only one LED per 2 slots or 3 slots or 4 slots. And that's because all of those slots are tied together electrically. And they are tied together in a series. Now, here's the difference between a series and a parallel circuit. Just try to show you very briefly. In a series, what happens is you have a piece of wire or a circuit, and then you have a device. And then you have another wire at the other end and another device. And it's a chain. But with a parallel circuit, it's multiple ones. So imagine that my arms are wires, okay, or cables. And my fingers are individual devices. This is like a parallel circuit. So we have 1, 2, 3, 4, 5 parallel circuits. They're parallel because they're all getting electricity along the same circuit at the same time. Even if they're not all drawing the same amount of electricity, it doesn't matter. They're parallel. If one of them is disconnected, the other 4 operate. If 2 or 3 or 4 of them are disconnected, the last one still gets power. But with a serial circuit, if any part of the circuit is disconnected, including a device, that whole thing stops working. And that's why when you buy Christmas tree lights, for example, if you get a Christmas tree light where one of the light bulbs burns out and then suddenly none of them work, and you're going through every single bulb trying to find the broken one, that is a serial circuit. But if you spend a bit more money and buy the parallel ones, when one of them burns out, all the others will remain lit, and you'll see right away which bulb has burned out, and you can replace it if you want to. I mean, 99% of the bulbs could burn out, and you still have one burning. I mean, lit. So what is better in your mind? I mean, do you really feel like having 2, 3, or 4 slots on one LED where all of the batteries are dependent on every other battery is a good idea? No, it's very inefficient, number 1. Number 2, all the batteries have to be the same. Number 3, all the batteries have to be plugged in. Number 4, the electricity is running through all the batteries. So that can delay things, as you might imagine. And it can heat up the batteries a lot. I mean, when I got this, I tried it, and one of the batteries was taking a long time to charge up, and I pulled it up before it was 100%, and it was hot. I was really surprised, even though this isn't a serial charger. But just avoid ones where there are one light per multiple slots. It's not a good deal. You think you're saving money, but it's actually going to wear out your batteries faster, potentially. Other things, what kind of voltage range does it offer? If it's like this one where it's plugged into the wall, this one has output of 1.5 volts. That's it. At either 300 or 750 milliamps. That's not much. This one, I don't know. There's no information on that one. I do have one more. I haven't shown it to you, and you'll understand here why I haven't shown it to you yet. This one is a different one. As you can see, this has got an LCD screen. It also has buttons. Everybody loves buttons, right? And this one is also powered by a Type-C connector. But the output of this one is either 0.5, 1, or 2 amps. You can choose that. And the voltage is 5 or 9 volts, if I'm not misreading this. It can go up to 20.7 watts, I believe. Now, this one supports a huge number of batteries. So the positive part about having a charger that supports a large number of batteries, and let me just show you. There are the ones that it supports. Is that you can use this charger to charge a lot of different batteries. But if you only have this one 4-slot charger for 2 dozen batteries, 3 dozen batteries, you're going to spend a lot of time waiting for open slots in your charger, right? So, and this is, you can do what you want here. You can buy some of these, which are always going to be less expensive, and for different kinds of batteries. So you can have different kinds of battery chargers for different kinds of batteries, so you don't have to be waiting all the time for this thing to get done with the batteries that are already discharged and are being charged. You can also look at slow versus fast chargers. One of the drawbacks of fast chargers is they tend to wear out batteries faster. Generally speaking, with many devices, including lights, if it's getting power at a lower level, it's actually tends to be better for it. It'll last longer. So, and that's something that you need to consider. You can also look at how many amps maximum can the charger provide? How many watts maximum can it provide? Can it discharge a battery? Can it or sometimes this is called refreshing. The reason is that some kind of batteries, like an IMH and an ICD or NiCad, nickel metal hydride, NiCad, and some of the lithium batteries have what's called a memory. It's not a deliberate memory. It is a limitation, I guess you could say, of the technology of that battery, that every time you recharge it, a little bit of space, electrical space, is lost because the memory is degraded, I guess you could say. It's not really memory. It's a chemical thing, as I understand it. But all you need to understand is every charge of some of these lithium batteries, or every charging, is going to decrease the total capacity of that battery. And eventually it'll get to be such a small amount that you won't be able to charge it anymore. And if all you've got are chargers like this that don't offer the refresh or discharging of batteries, you'll end up throwing them away when they're actually still good. Because what you can do with one like this, and this only has one slot that does the recharge function or discharging, but this one slot, or any battery charger that offers refresh, will drain the battery to zero and then recharge it. By draining it to zero, that resets that memory, that so-called memory, and puts it back up at not necessarily 100, but as close as it can get to 100. Now, you don't want to discharge 100% on every type of battery. Some batteries do not like to be charged, or discharged, below 50%. It'll actually destroy the battery. Some batteries don't like to be discharged every single time. It's better to get it to a certain percent and then charge it. Some products will fast charge your battery to 80%, and then it'll slow down. And that is a good thing. It takes longer, but it's actually better for your battery because it extends the battery's life, because it's not pushing all the electricity to 100% at maximum current, which is amps. What else? So get the cheapo ones like this so that you can easily charge a wide variety of batteries. And please don't put the disposable batteries in these unless it specifically says it's designed for disposable batteries to be recharged. Most are not. So you can have one for AA's and AAA's, one for 9 volts, one for C's and D's, and one for 10,000s, one for the lithium. However you want to do it. It depends on what kind of a range and how many batteries you're dealing with. I mean, I try not to buy things that rely on batteries. I don't really like that because batteries are expensive, especially if you rely on the disposable ones. But you do what you got to do. Another thing that you can get from better battery chargers, and again, this is important to have one of these that serves many different kinds of batteries and can do the discharging or refreshing. This one also offers, in this 4th slot, testing. So what it'll do is it'll charge up the battery, and it'll discharge the battery, and then it'll charge it up again, and it'll let you know what the results are in terms of how good the battery still is. I don't remember if I mentioned this. If you know how to discharge a battery on your own without getting something like this, you can do that and then just charge it up. You won't know how much life it has left or whatever, but you'll be able to get by without a discharging unit. The nice thing about ones like this is that it has a display that gives you information. I'm going to turn that. So you get to see volts and milliamp hours and percentage charged. And by pressing the slot button, it'll switch between each of the active slots and show you where each of them is at. So we can see that this one is already finished, the 16850. And this one, the second one, is at 78%. And the third one is at 40%. We can also see that this has got 1.29 volts. And it'll switch over to amps. It's charging at 0.5 amps, which is half an amp or 500 milliamps. We can see that this one has 4.18 volts. And it's not charging because it's at 100%. And we can see that this one is charging at 0.5 and has 1.47 volts. And now it's 92%. So that's useful to let us know. It also tells us for each of these what kind of a battery, what chemical composition it has. So this one is either a nickel metal hydride or a nickel cadmium. And so is this one. But this one over here is a Li-ion. It also says this is a 4.2 volt. So you can get that information about each of your batteries as well. And that's nice. Now you'll notice that this battery is no longer charging. Why is that? Well, there's a flaw in the design of this. And that is that because this takes the lithium batteries, the channel has to be very wide. And that makes it difficult to seat this correctly. Now, there's one of two ways you can do it. And the easiest way is to push down on the slider with the butt of the battery until you get it to the point. And if you look here, you can see there's like a double nub here. What you want to do is get the nipple on the second nub, and then it starts to charge again. It's a little bit awkward, and you can accidentally nudge it when you're working with one of the other batteries, but that's okay. And in order to do discharging and testing, you have, say, this one, put it in here, and then what you can do is, in order to test it, you do you press both buttons and hold them down, and then that triple thing starts, and that shows you that it's starting to work on the test. If you want to just do a discharge, you do it until that happens, and then you press the mode button, a short press, and it'll go into discharge mode. And there are other battery chargers that are even more advanced than this one. But I'm happy that I have all three of them because I never know when I'm going to have to charge my batteries. And I want to go back to the milliamp hours for a second. So this is nickel metal hydride. And usually batteries will show you at least this much information. Nickel metal hydride, AA, 800 milliamp hours, 1.2 volts. Okay? And this one is, we can see 1.2 volts, 2800 milliamp hours, AA, HRD6, Mignon. I don't know what that is there for. I think it's a little bit strange, but, and you can see in very large letters here, 2800 milliamp hours. 2800 milliamp hours, again, is a reference to how many amps per hour, or something to that effect. It's been a long time since I studied that kind of stuff, so I may be saying it the wrong way. And then we have this one, looks the same, almost the same as this one. This is 800 milliamp hours. This is 2800 milliamp hours. But otherwise, they're both the same chemicals: nickel metal hydride and 1.2 volts and AA. This one is Yunpao. This one, I don't know what the brand is. It came with, forgot. Oh, I think I bought that separate. Oh, I know what that came with. That came with a piece of junk bug zapper that died within a few days. And then if we look at this one, you can see it's an 18650, 4200 milliamp hours, 3.7 volts, lithium ion. So there's a wide range. And again, if you have something that has a low power draw, you can get something with a low milliamp hour rating because it won't make a difference. But if you really want it to last longer, you can get something with higher milliamp hour. If you've got something like a camera, get something with a lot more milliamp hours in it, because cameras, especially the flash, suck up a lot of electricity, and they do it quickly. What else? In addition, this one also will allow you to, like I said before, choose between charging at half an amp, 1 amp, or even 2 amps. And that can be good, especially if you've got something that has a very large capacity. Another thing that you should look at is what kind of protections does the battery charger offer. I don't know if these two have any kind of protections on them, other than they stop when the batteries are charged. This one protects from short circuiting, it protects from overcurrent, and there are other protections like overcharge protection that all three of these have. This battery, whereas many of the other batteries that I have to be discharged to restore the memory, so to speak, or the full capacity, this one has a circuit built into it so that it automatically does that for you. So you never have to actually worry about putting this one into a discharger because it takes care of it by itself. And some types of batteries don't have that memory issue at all, and they don't even have a circuit. They just automatically, they're not vulnerable to that particular weakness. So, just to recap, and like I said, look at the power source. If you're using power source from the wall, you have a higher potential for the watts and amps that you can get out of it. But ultimately, it depends on how the device converts that electricity to allow how much is going to actually be provided to the batteries. So get some battery chargers that are specific to the batteries that you use. If you have a certain type of battery that you're charging or that you're replacing every few days, you should probably have a battery charger that has maybe 8 slots or 10 slots or 2 battery chargers or 3 battery chargers. If different family members are using it, you probably want to get each member of the family a battery charger and say, when your battery stops working right, don't throw it away. We'll discharge it and recharge it if it's not one of those, if it is one of those kinds that has a memory issue. And then make sure to get an advanced one like this to allow you to be able to do that discharging and testing and the other advanced features that this offers. And again, there are others that are more advanced than this. There are some that will not only charge all of the ones that we've been talking about, including the 9-volt. They'll have a thing, like sometimes it's down here, or sometimes it'll be on the side, where you can plug in a 9-volt or two, which is great. I mean, 9 volts are nice to have, and I really hate, putting a 9-volt into my fire alarm every year, and then I have to throw it away after a year. Even if it's a lithium, it doesn't last that much longer. So I hope that this has helped. I will try to answer questions that you may have. I am not an expert in this, but at the very least, I hope this encourages you to consider going to the rechargeable batteries, which will save you so much money. And that's good for the environment, and that's good for your pocketbook. Everybody wins. Oh, one final thing. Please remember, with rechargeable batteries, when they're finally really dead, don't throw them in the garbage. They need to be recycled properly, because lithium is dangerous and cadmium is even more dangerous. It's a heavy metal. It's toxic. Lithium and cadmium and these other compounds getting into a landfill and then breaking down and getting into, say, your water supply is not something you want to have happen. So make sure you take advantage of your local recycling program, which you'd have to check with like City Hall or something to find out when or how often that it's being provided. Some big places, you can do it pretty much all the year round. Other places, they only have it once a year, and some places don't have it at all. First of all, you need to understand that when we talk about cells and batteries, the thing that we call batteries in general are not batteries. They're cells. People don't know this because common language has taught us that those individual packages are batteries. Batteries are multi-cell. Those things we buy in the blister packs at the stores are cells. So when you take a bunch of them and tape them together and wire them together, then that's a cell. Put a bunch of cells to put together, to form a battery. Thank you very much for watching. I hope this helped you. Have a wonderful day.
Need to ask for your help. I'm sorry. On December 11th, 2024, Amazon terminated me and used false accusations against me. And on December 17th, I had my left shoulder operated on. I'm getting a lot better. I can do some things with my hand and my arm, but it's still pretty limited. If you could please help me out by liking, subscribing, sharing, commenting, and turning on notifications for my channels, that would really help. If you want to help me financially and you can afford to, you can go to my Glenn's Fast Reviews and you can do a super thanks as a donation there. If you want to donate on a monthly basis, you can become a member there. And or you can go to patreon.com/GLENNMII. So thank you for that. Also, I'd like to say thank you to bleepingcomputer.com for allowing me to post messages on their forum about my videos. Thank you so much. And don't forget to visit them. They offer a lot of wonderful resources for people who are using computers. Have a wonderful day. Thank you.